8 ways to use logic to breathe life into code. Welcome to Insight Builder channel, programmers, problem solvers, and my dear friends. Before making a machine move, let's make it sense. The reason why I'm making this video is that we have to think about how to get more data and enumerate the data inside a code, inside your program. Before we can do that, we have to first of all understand how we can make the mission sense. So we are giving a simple data to the mission, and the mission has to respond. In the earlier video in the series of playlists, you would have already seen how the mission can be given inputs through 5 different ways. After the input has been taken, the mission has to sense it and do something with it. So first and foremost, sense is basically logic, and logic is sense. You'll be seeing that logic plays a vital role in how missions actually live. And one of the important point I wanted to make before we dive into the next part of the video is that world that we are living in is continuous, meaning that this moment in time and the next moment in time has no visible gap, so it is continuous in nature. Even if you take your skin, your the table that you're sitting, the monitor that you are viewing, everything is continuous in nature. But the moment you are going to put any of these things inside the programming machine or inside the code, it is going to become digital in nature, meaning it is going to be either zeros or ones. Logic is digital, but the world is continuous. So logic is either true or false. There is no middle ground in logic, but in the world there is always a middle ground. Our challenge is to use something that is in the real world which is continuous and then make the machine or the code sense it. So that is one of the challenges that we will be slowly and steadily uh, covering in this series of videos, but this video is going to be the starting point of it. So logic actually gives senses to the machine, and once a machine or a code or a script can sense, then it actually simulates life. Yeah, in fact, if you go to Britannica, the encyclopedia, you will see that life is defined as many things, and the final step is responding to external stimuli. So when I am talking about inputs, we are talking about external data or external stimuli. And once we give that data to the code or the script, and if it is able to respond, then we have actually given life to that particular script. When it comes to the programming languages, there are very different ways of creating the logic syntax in each of the programming languages, but the logic is same. Every programming language will have greater than, equal to, less than logic. There will be some way to handle the exceptions, meaning the error that is getting thrown by your code that you write. There will be some way to test the development that you're doing, the code that you're writing. And then there is also some ways of comparing the strings or the status or the states of a particular variable. So uh, in case of Python, at least, there is not, there is, and there is contains. So these kinds of functions or keywords are useful in deducing the state of a particular script or a particular situation inside the code. Okay, this is a very a high level introduction to how logic or why logic is there, because most of us, we learn excuse me, we learn about logic. We know how greater than or less than or equal to works, and we know how the boolean true and false, all these things happens. But the point is, why are we doing this comparison? Because the machines cannot sense. The machines can take the data, but in order to make the machines or the code to sense the data, we have to write the logic. Then only after sensing it, the machine can decide that, okay, this particular data is a number, or this particular data is an object, it's a picture, it's a text file, whatever it is. So after that, it will go to the next step and do the processing. So this is one of the important steps that we have to understand, and also we have to learn why it is useful. Now that we have seen that how uh, logic actually breathes life into the code, and what are the various ways the logic can give senses to the machine, and why it is important to have sense, let's actually go into applying the logic. So this particular code is going to run through a couple of important logic that we have read so far. In order to make it little more legible for you guys, I have modified the command prompt to make it a little bit bigger, and I'm going to execute the code first. Applying logic, and the moment I start applying the logic, that is the immediate prompt. It is asking me for the user input. It's asking me to choose between 1 and 2, and it's having some cryptic instruction here. It's saying 1 colon fwd and 2 colon bwd. Anybody who is coming and using this script for the first time will be clueless about what is this fwd and bwd. You can actually guess that fwd can be forward and bwd can be backward, but the best way to actually find it out is just to enter the numbers and see. The moment I enter the number, I see you have entered a number, the code is talking to me, and it is saying move forward. And after that, we see that it is going to the next step. It is saying the fuel tank capacity is 15 and the available space is 7, and there is a kind of a symbol, or kind of a visualization that you can see here, that which says that there is 15 points here, and out of that 8 points are filled up. So it is now asking me how many liters you want to fill. So from all this data that the script is providing, we can think that, okay, this is some kind of a tank, and it is asking me to provide a number that it can fill it. So I'm just going to give a number 3, and once I do that, it's saying there is minus 4 liter space available. So this is actually wrong. You see, if you code wrong, if your logic is wrong, and if your internal formulas are wrong, you are going to get the wrong answer. The machines can't actually change whatever you're coding. It can only do whatever you're telling it. And you, as a coder or the programmer, has to know the logic and use that logic to make the machine work for you. Okay, that is about the numbers. So here we used a number, and then here also we used some numbers, we did some comparisons, but now we are going to compare strings. So here we are talking about jasmine, sunflower, and lily. I mean, all colorful flowers, right? And all these are words. These are all letters. So how is this letters getting recognized internally by the machine? So there is something called as ASCII code, where all the individual characters of the languages have been converted to numbers, and the numbers are already hard coded inside the processor, or inside this operating system, and inside the programming language. You don't need to really know to that extent, but knowing that the letter S, letter U, letter N has a numerical value inside the programming language actually helps. So if I type sunflower here, and if I press enter, it will immediately say, here you go, enjoy. It means that it is able to provide me a sunflower, and it's asking me to enjoy with it. And then again, it's saying that I have all these flowers, which flower you want to use, you want. But now I want to try something else. If I say daffodil, you'll see that it is responding that it doesn't have daffodil flower with it. So depending on the inputs that I'm providing here, the system is able to respond to me, and it is responding to me in text. It's like playing a game, or having a chat with a system, with your friend or whomever it is. But we clearly know that this is a script that has been written in Python, and we are interacting with it, similar to ChatGPT. So if you guys have enjoyed the company of the AI model ChatGPT, at the back end, there is a model, AI model, that is able to generate the text and it is providing it to you back. But to us, whenever we are trying to discuss with it, we feel as if it's more than a code or more than a script. We'll be diving into those concepts as we go further in this series of videos. This is a starting point where we are hard coding the logic. And now finally, it's asking me, okay, how many flowers you want? So I say 3. This is the number I'm going to give, and it is saying I'm sending 3 flowers to you right away. Okay, in all these steps that we went through, there was only one error. Okay, and even that error was not actually flagged as an error by the code. Only we know. After we read that, I mean, there is -4 liters seems like there is a logic problem, or there is a typo that has been made in the formula, because we have 15 liters capacity and the available space is 7, meaning if I'm going to fill it with 3, that should be plus 4 liter available space, not -4. And now what we are going to do is we are going to create some illogical things. So instead of 1 and 2, if I say 4, let us see what happens. So it's saying just waiting. It is not able to recognize anything apart from 1 and 2. And in this case, if I am going to type something that is not a number, so if I say 7, you'll see that it immediately throws an error and the script ends. Only the script has been coded in such a way that it can only sense the number, not the text. And this is one of the challenges that has been resolved in the next step. So in the next step, where we are trying to work with the words, the internal code has been written in such a way that it can compare the strings, not the numbers. So here, if I try to give number 7, it will still say, sorry, don't have 7 flower with me. So here it is saying, it is thinking that 7 is a string. The idea of the number 7 and the string 7 is also a concept that if you're a beginner programmer, then this is something that you will have to understand. So how the string and how the number is different, and what kind of operations you can perform on string and number. Because at the end of the day, whatever data that you are providing into the code or into the script, into the programming language, is there to be operated upon, meaning to be worked upon. So if you have to work upon something, it means that you need to know what kind of work you can do on that particular data. Like in case of 7, you should know that, okay, this is an integer, I can do add, multiply, subtract and divide. But if it is string, then you have to know that, okay, I can compare it with another string, I can actually add it to another string. So such things. So this is what you will have to understand, and we will dive into this slowly and steadily. Next, I am going to give a good name. I'm not going to break this time. So I'm going to say Lily, which is part of this flowers. But now what I'm going to do is, instead of saying 3, I'm going to say 1. What happens is, I'm sending 1 flower to you. So this has worked. But then it says that I can send only 3 flowers, 3 numbers of flowers. So I am throwing an error. And it is throwing an error at me. And for throwing an error, it is using something called as assert. Assert is a keyword. It is available in most of the programming languages. Assert actually checks whether a particular variable and the value of that particular variable is equal to a particular value. This particular activity is provided to throw error whenever there is a mismatch. So this can be used it is actually used in test driven development, where the values of the output is checked with the correct value. And that is how the test driven development happens. The single word assert is used in almost all the testing frameworks. Whether in case of Python, whether you're using PyTest or whether you're using unit test or nose, whatever testing framework you're using, the way to compare the values between the actual value and the value that has to be there. In fact, here the value that has to be there is 3. If you give any other value, then it will throw an error. So like this, comparisons is done through assert only. Okay, so here we have actually dived into the we dove into the entire ways of looking at the logic. We have seen how the logic is useful when you are running the code. But for next 5 to 6 minutes, I will be walking through the code that was used to build that script that you saw right now. It starts with the user input, and this code is fully documented. I have provided sufficient amount of comments here in green. You can see that. I would suggest that you guys also get the VS Code. It's one of the best available IDE in the market right now. Currently, the user input. So this is the first input that we got in. So choose between 1 and 2, and you can see that in this place, I am first of all checking that whether the user input is an integer. So what if I don't give an integer? So let us try that. So instead of giving giving the number, I say FWD. So you will see that immediately here it throws an error. Okay, and it is saying invalid literal for int with base 10. Basically, it's saying that it cannot convert a string, that is FWD, into an integer. This is how the program tells to you that you have made a mistake. But as we saw, we can actually use something called as try and except. So I'm going down further so that you guys can see the try and except block. So here I am telling that this is going to be an integer, and if I'm able to convert the input, so I'm getting an input in the variable flower quantity, and the input is how many flowers you want. If I'm able to convert it, then it will be able to tell that I'm sending this many quantity of flower to you right away. But if I don't give a number, if I give a string there, or if I give a text value there, then it will say enter a number only. This is how you can make the code to respond to the stimuli that we are giving, whether it is right or wrong. As you can see here, the main driver is the logic, how you are using the logic, and what kind of keywords and functions are implemented to use the logic. Let's continue further. Next, we see that if the user input, so here you can see the comment using only equal to. So I'm only using equal to, and the equal to logic is double equal to sign. You can see that user input, I'm checking it whether it is 1, then I'm saying it's move forward. If it is user input 2, then I'm saying move backward. If anything else, then I'm saying print waiting. So you can right away see the logic by reading the code. Whatever the input the user is giving, the appropriate output has been already hard coded in the program. The code or the programming language cannot change it. It moved forward, and the print statement is telling fuel tank capacity. So here I had already hard coded the capacity of the container and the available capacity. And here we are trying to check the fuel tank capacity and print it. And also here we are using basic mathematical calculation of subtracting and getting the available space. After that, we are printing this 4 lines help to print this kind of visualization. So it's a simple visualization that has been built using the print functions inside the Python framework. Like this, there are many things that can be done. There is something called as ASCII artworks. Using simple ASCII symbols like this pipe, underscore, hash symbols and at symbols, you can build really interesting and good looking arts. So it's and it is done programmatically. It's a challenging way of working with code and get the things done by the system. So it's just a digression. Moving forward, here we are comparing using the less than or equal to symbol. So, and here we have greater than symbol. So the way we are using the numbers and checking them, whether the container availability is there, whether it is less than or equal to the container capacity, and if it is less than or equal to, then we are saying, okay, how many liters you want to fill. If it is over, then we say the tank is overflowing. So let me show you what happens. So I'm going to execute this. I'm going to execute that. And I want to say, instead of 8, I'm going to say 10. And the moment I do this, so it is saying that wasted 3-liter fuel. Basically, I have overfilled the tank and extra 3 liters has been filled. So we can actually write the code, and you see in the code, I mean in the execution, it's just 2 lines. So you see that it is asking me to enter the input here, and you see the tank is overflowing in the next line. But inside the programming code that has been written, it's a lot of code that has to be typed. So some call this boilerplate code, and others call this an option for converting this to functions, where you can call the function to make the visualization. We'll be seeing those things as we go further into this discussion, because the same code we'll be using it again and again, but we will start refactoring it. So that concept also we will discuss as we go further. Anywhere there is a repetition in programming, we have to avoid it, because there is something called as do not repeat yourself, dry principle. So whatever I've done here, I have repeated myself. So I have printed 5 times, and here also I have printed 5 times, which can be avoided. And we can reduce the number of lines the execution has to go through. Okay, so this is how we are using less than and greater than. After that, we start comparing the strings. So comparing the strings is very similar to just using equal to. It's not something that we use is or not or anything. We are just using simple equal to, because internally these are actually having some kind of numbers assigned to it, like sun internally will have numbers. And when the flower variable has contains the same set of characters, then they will become equal to each other. So that is how it is working. And if it is having a empty space, even empty space as a number, right? So that's how it's getting compared. And if none of the values that we provided matches, then it will say that it doesn't have the flower. And then comes the not. So one of the major challenges that newcomers to programming face is this not, how to use this in logic. It's actually complex if you don't understand the purpose of not. As of everything in programming and coding, it always depends on how you understand the particular concept. So let us go back to the applying logic. And here what I'm trying to do is, I'm saying that if the flower variable is not containing jasmine and sunflower and lily, meaning if the flower input variable is not containing any of these variables, jasmine, sunflower or lily, then you should say that sorry, I don't have the flower with me. If it contains anything else, then it will ask you type of flower name. If it contains these things, then it will say here you go, enjoy. Why am I using this not here? Why I cannot just go with this positive way of comparison? There are certain locations in the coding where you have to use the negative comparison. So this is a positive comparison, that we expect that flower to have jasmine or sunflower or lily. But in certain places, you might have to do it the opposite way. Knowing when to use and how to use both positive comparison and negative comparison is also one of the important tasks when it comes to learning to program. Okay, finally, we discussed about try and accept already, and also the assert in the beginning of the discussion itself. Try and accept any code that you want to try to execute, and if it fails, then it is going to execute the code that is in the accept block. So this is called as a block in coding. So this 2 lines are called as a try block, and this 1 line is called an accept block. In the try block, there can be many lines, so in the accept also. So there is no restrictions on the number of lines. However, keep one thing in mind, keep it as simple as possible and give a lot of comments. So here I've already told catching errors and informing the user. So here the error is caught, and here the user is informed. Finally is the assert. So this is the keyword that is used in test driven development most of the time. And most of the time when you're going to use any kind of test frameworks like pytest or nose tests, unit test, whichever framework that you are behind, this test driven development is going to use some kind of assert functions. Assert is prevalent in Python. In case of JavaScript, in case of other programming languages like Rust, will have different keyword, but the concept is similar. So we have come to a close of this brief discussion where we provided 8 different ways to use logic to breathe life into code. I believe that you have got some clarity on how the logic can be used, and how creatively you can start writing code, etc. The idea of this particular video is to spark interest in creating programming scripts, which you can use it for day-to-day activities, or even for fun to create some games or anything. So I hope that you will use this as a curiosity tool. Till the next video, stay tuned and have a great time, dude.